Okay, so here are the steps for respiration. The idea here is for us to break down sugar and form ATP. So we're going to first write our equation. We have oxygen and glucose yielding CO2 and water, and of course ATP is made. Glycolysis occurs in the cytosol. We're going to start off with glucose. I'm going to show it as just carbons, but you know that it's C6H12O6. I'll draw it as 6 carbons just to make it simple. We're going to add ATP to it, 2 ATPs. That's going to make it a little bit unstable, and it's going to split into 2 molecules, each with 3 carbons. Then we're actually going to make 4 ATP and 2 NADHs. And NADH is very similar to NADPH, which we use in photosynthesis. Does the same thing, it just carries around high energy electrons. So that leaves us with 2 3-carbon molecules, and each one of those is called pyruvate. So we're left with 2 pyruvates. For our summary here, we're going to say that we made a net gain of 2 ATP, 2 NADHs, and 2 pyruvates. So just so you know, pyruvate does have oxygen in it, and we're going to strip some of those oxygens and hydrogens actually away later on in the Krebs cycle. Our pyruvate molecule is the molecule that's going to move on to the Krebs cycle. We're going to follow 1 pyruvate molecule through the Krebs cycle, but just remember that 2 are made each time you break down glucose. So here are our instructions. Step 1. We use 2 ATP and we break down glucose into 2 molecules. Step 2, ATP and NADH are made. And let's do it over here. Step 3, 2 pyruvate is made. And that's about it for glycolysis. We just use a little bit of ATP. You have to give a little to get a little. We make our 4 ATP later on, giving us a net gain of 2. We have 2 NADHs and 2 pyruvate, which will enter the Krebs cycle. And you might be wondering, well, what's the point of making the NADH? That is used in the electron transport chain to produce all of our ATP. And I'll go over that later.